Hello, welcome to 7.3. We are talking derivative of inverse functions, and I'm going to start off the video talking a little bit of a recap on inverse functions, and we'll get to derivatives. All right, so at the right here, there are graphs of a function f of x and its inverse f inverse of x, right? That's how we read inverse notation. Remember that the graph of f contains a point a comma b. Then its inverse will contain its image point, which is x and y switch, or the ordered pair switch. So if it's a comma b, then it's going to be b comma a. Okay, and it's a unique reflection across the line y equals x. Okay, so it says, from the graphs above, do you see a relationship between the slope of the graph at f at a comma b and at b comma a on f inverse? Okay, so we'll kind of investigate that relationship here. So example 1, it says let f of x equal the square root of x, and they want us to sketch a graph of f of x. Okay, so 0, 0, 1, 1, 4, 2. There is y, or f of x here, right? F of x is the square root of x. And then it says find f inverse of x. Okay, so if f of x is equal to root x, I'm going to make this multivariable. So y is equal to the root of x, and I'll switch x and y. And then I'm going to go ahead and solve for y. So lo and behold, our function f inverse of x is equal to x squared. And it says, note, you must list a domain restriction. So for our inverse function, what's our domain? Well, x must be greater than or equal to 0. Okay, so there's our inverse function. And what I'm going to do in part C is sketch this. So they want us to sketch f inverse of x. So 0, 0, 1, 1, 2, comma 4. So here is our inverse function. Okay. Now it says differentiate both f of x and f inverse of x. Okay, so if f of x is equal to the square root of x, which is x to the power of 1/2, then f inverse, or sorry, f prime of x is equal to 1/2 x to the power of -1/2. F inverse of x is equal to x squared. So therefore, the derivative of f inverse of x, right, f inverse prime of x, it's kind of like a tongue twister, is equal to 2x. Okay, so what? Well, let's keep going. It says find the slope of the graph at 4, 2 for f of x, and the slope of the graph at f inverse of x at 2, 4. So notice that these 2 points here are image points. They're reflections of each other. Okay, so f of x at 4. So if I want the slope of the graph here, I'm going to plug it into f prime. So f prime of 4 is equal to 1/2 times, that's 1 over root x, which I want to plug in 4, square root of 4. So that is equal to 1/4, right? Okay, so now I'm going to do the same thing. It says find the slope of the graph of f inverse of x at 2, 4. So I'm going to take f inverse prime of my x value at 2, and I plug that in, and that's 2 times 2, which is equal to 4. So it says, what conclusion can you make about these slopes? So 1/4, 4, 1/4, 4, they are reciprocals. So they are reciprocals. And that is pretty much it. Inverse functions, their derivatives are reciprocals. Okay, that's the conclusion. So since the slope of equals, which is m, which is delta y over delta x, it should make sense that switching x and y for inverse functions should produce reciprocal slopes for inverse functions, right? The change in y over the change in x, okay? So moving right along, here is our conclusion. It says if a comma b is a point on f and b comma a is a point on f inverse, then f inverse prime of b is equal to 1 over f prime of a. Pretty much, again, what we're talking about, that these functions, their derivatives have reciprocal slopes. Reciprocals. Okay, not opposite reciprocals. That's, you're thinking about the normal line. Okay, just reciprocals. So sign does not change. Okay, notice that if f and g are inverse functions, you can also use this notation. However, we will mostly be utilizing the notation above. Okay, so derivatives of inverses have reciprocal slopes at image points. Okay, so if a comma b is 1 point, then the slope will be the reciprocal at b comma a for the inverse function. Okay, when finding derivatives of inverse functions, do not use the same x value for f and f inverse. So going back to this example up here, notice I didn't evaluate. Here I used 4. I didn't use the same x value for here. I had to use its ordered pair with it, right? So the image point. Okay, so here's what we're going to do. We're going to look at a couple of functions, f and g, that are inverse functions, and we're given some information here, and then we're going to be asked questions. So they tell me f of -1 is equal to 1. So in this chart here, I have this point, f of -1 is equal to 1. And they tell us the slope here, f prime of -1 is equal to 3/2. Okay, so f of 0 is 2, so at 0, the output is 2, and it's saying at 0, the derivative, or the slope, is 2. Okay, again, f of 1 is 5, so then f prime of 1 is equal to 1/2, so there's the slope. Okay, so I have these pairs. If f and g are inverses, right, if g is equal to f inverse, then all of these ordered pairs are going to switch. That g of 1 will be -1, g of 2 will be 0, and g of 5 will be 1. Okay, and what happens with the slope? Well, they are reciprocals. So the slope of g of 1 is going to be 2/3, the slope of g of 2 is going to be 1/2, and the slope at g of 5 will be 2. Okay, so it says, from the given information, find each of the following if possible. Hint, make a chart or a table to organize your data. We had that given to us here, so if you have these problems, you might want to make a table similar to this one in your homework, okay? So they say, what is g prime of 1? So I look at my function g, here's g, and I say, okay, where's the x value? 1, it's 1, and what's the slope there? 2/3. Easy enough. What's g prime of 2? Hey, it's 1/2. What is g prime of 3? Well, I don't have any information, so we are going to say unknown. Don't give an IDK. Don't write that, right? Unknown. G prime of 0. I notice my function g doesn't have an output of 0, an x value of 0, so this is, again, unknown. And watch out. They are going to try to trick you here. Here's what someone will do. Someone will say, oh, here's a 0 that matches g. I'm going to write 1/2, and the answer is unknown. You don't have any information. G prime of 5. So where's the x value in g? 5. Here it is. Okay, and what's the slope there? Right, that's what the apostrophe means. That means g prime of 5, and that is 2. So there you have it, folks. That is the derivative of inverse functions. They're reciprocals. That's it. Catch you next time.